Okay, I could tell that last class we were having some issues with this this worksheet or pamphlet or whatever you want to call it. And so it seemed like we could all do this part where we looked up the wavelength from using the visible light spectrum, and we could also look up the frequency by looking that up as well. So the problem started with number 2 when we were converting to wavelength to meters and we were calculating for the frequency. So I wrote it all out in words to hopefully explain myself more clearly. So we are going to be working with copper. And so if you notice, copper gave us a 550 nanometer wavelength. So I wrote it all out, so I'm going to read it to you and hopefully explain it a little better. So when lit on fire, the copper salt gave off a blue-green flame. Okay, this blue-green flame was light. Okay, the blue-green flame had a wavelength of about 550 nanometers. That's what we looked up. Because this color is a version of light, it will have an overall speed of 3 times 10 to the 8th meters per second. Okay, all light has this same speed. We can use that for all light. Okay, so therefore we can write C for speed of light, is equal to 3 times 10 to the 8th m over s. That stands for meter per second. So the only factor that we do not know is frequency, which is measured in inverse seconds. Okay, inverse seconds is 1 over s, or s to the minus 1, or sometimes that is referred to as hertz. A known fact is that any light's wavelength and frequency multiplied together, any light's wavelength and frequency multiplied together equals the speed of light, which is c. So this can be mathematically expressed as c equals lambda v, where c equals the speed of light, lambda equals the wavelength, and v equals the frequency. Now again, the speed of light, c, is equal to 3 times 10 to the 8th meters per second. Wavelength is different for every color, so it will change, but it will always need to be measured in meters so that these meters can match these meters. Let me see so that these meters can match these meters. And then frequency is measured in inverse seconds, 1 over s, okay? So knowing this equation, we can solve for the unknown, okay? So in this equation, we can solve for what we do not know, the unknown, which in this case is frequency, or V. Because for copper, we knew that the wavelength given off was 550 nanometers. So we know the wavelength, or lambda. And then since it was a light, we always know that C is equal to 3 times 10 to the 8th meters per second. So the only one that we do not know is V. So that's why we have a question mark. Now, if you notice, we wrote right here, we wrote lambda equals 550 nanometers. But in the formula, we are working with meters. So this and this do not match. Okay, so if you notice, the speed of light is measured in meters per second, but the wavelength is currently in nanometers, nm, which means nanometers. We must first make the units for speed of light and wavelength match by converting or changing the nanometer to meters. This is how we do that. 550 nanometers is equal to 550 times 10 to the negative 9 meters. Because nano stands for times 10 to the negative 9. So we can replace this n with times 10 to the negative 9. If you notice, everything else stayed the same. We just replaced the n with times 10 to the negative 9. So now we have that lambda is equal to 550 times 10 to the negative 9 meters. So now our units match. So now we can plug this information into the equation from before. C equals lambda V. Okay, that was the equation. Well, I have right here that C is what we know. This is the speed of light. It can go into this place. Lambda, we just found that, and now the units match. So lambda can go here, but we still don't know V. That's still in question. So let's plug their numbers into their variable and solve for what we don't know, which is V. So let's break this down. I put this in for C, put this in here. I put lambda in the 550 times 10 to the negative 9 in for lambda, still solving for V. So at this part right here, I have plugged into the equation. And then I am solving for V. So I want V to be by itself on the equation. So to get it by itself, I need to divide each side by lambda. So I divide this side by lambda, I divide this side by lambda. This one crosses out and I'm left with V. Okay, this one, I just bring this down and I say V equals 3 times 10 to the 8th divided by 550 times 10 to the negative 9. If you put this in your calculator, just the numbers in parentheses, just like this is the number that you will get. And remember, V stands for frequency, and frequency is measured in hertz or inverse seconds. They are the same thing.